ChatGPT, Claude, Gemini, Google search. Your phone's autocomplete. Every single one of these runs on one invention. One. And nobody ever explains what it actually is, until now. Hey, I'm Maggie, and today we're going under the hood. I'm going to explain the single most important invention in modern AI, the transformer, in a way that actually makes sense. No math, no code, just the idea. By the end of this video, every time someone says GPT or large language model or neural network, you'll know what's actually happening inside. I promise. Let's go. Before we get into how it works, let me show you something. You already use transformers, like constantly. ChatGPT? Transformer. The T in GPT literally stands for transformer. Claude? Transformer. Google search giving you those AI summaries at the top? Transformer. That autocomplete on your phone that somehow knows you're about to type "on my way"? Transformer. Google Translate? Used to be terrible. Now it's actually good. The difference? They switched to transformers. Every major AI model on the planet, GPT, Claude, Gemini, Llama, Grok, they're all transformers. There is not a single major AI that isn't built on this one idea. So what is a transformer? Okay. I want you to imagine a library. Not a fancy one, just a normal library with books, a catalog, and a really good librarian. You walk in with a question. What's the best restaurant near the Eiffel Tower? Now, the librarian doesn't just randomly grab books. She does something clever. First, she looks at your question and thinks, okay, this is about restaurants, Paris, and recommendations. That's her understanding of what you're asking for. Then she goes to the catalog. Every book has a little card that says what it's about. French cuisine, Paris travel guide, Michelin stars. Those cards are like labels for what each book contains. She matches your question against the catalog cards. Some match really well. Some don't match at all. The ones that match? She pulls those books off the shelf and reads the actual content. And here's the magic. She doesn't just find one book. She combines information from multiple books. A little from the travel guide, a lot from the restaurant review, a pinch from the Michelin guide, and gives you a single perfect answer. That is attention. That's the whole thing. That's what makes a transformer work. In the real transformer, your question is called the query. The catalog cards are called keys. The book contents are called values. And the librarian's skill at matching your question to the right books? That's the attention mechanism. That's it. That's the core idea. Everything else is details. All right, let's walk through the actual machine step by step, starting with how it reads your words. When you type something into ChatGPT and say, "What is the capital of France?" The model doesn't see letters. It doesn't even see words. It sees tokens. A token is a piece of a word, usually a full word, but sometimes parts. Transform and ER are two separate tokens. The word transformer gets split in half by its own technology, which I find hilarious. So your sentence becomes a list of token IDs. Just numbers. What might be token 2039? Capital might be token 5765. The model works entirely in numbers. But here's the thing. The number 2039 doesn't tell the model anything about what means. So there's a second step. Embeddings. An embedding takes each token number and converts it into a list of hundreds of numbers that actually capture the meaning. King and queen end up with similar embeddings. King and banana? Not so much. Think of it as translating words into a language that math understands. Once the words are embeddings, the transformer can start doing its real work. Okay, this is the big one. This is the part that made the transformer revolutionary. Self-attention. Remember our librarian? She takes your question, checks every catalog card, and figures out which books matter most. Self-attention does the same thing, but with words. Let's say the model is reading, "The cat sat on the mat because it was tired." The word "it," what does it refer to? The cat, the mat, the tiredness? A human knows instantly, it's the cat. But how does a machine figure that out? Self-attention. Every word in the sentence looks at every other word and asks, how much should I pay attention to you? It looks at cat and thinks, high relevance. It looks at mat, low relevance. It looks at tired, a medium, because tired is what it is doing. And remember the library? The word doing the looking is the query. The words being looked at have keys, basically labels saying, here's what I'm about. And they have values, the actual information they carry. The attention score is just, how well does the query match each key? The better the match, the more that word's value gets used in the result. But here's what made the 2017 paper so special. The transformer doesn't just have one attention process. It has multiple heads, like having 8 librarians working simultaneously, each looking for different things. One head might focus on grammar, another on meaning, another on which words are near each other. They all run in parallel and combine their findings. This is why the paper was called Attention is All You Need. Before transformers, models read text one word at a time, left to right, like looking through a keyhole. Attention lets the model see the entire sentence at once. And that changed everything. After attention figures out which words matter, there's one more step before the output. The feed-forward network. Think of it as the reading room in our library. The librarian found the right books and figured out which pages matter. Now you sit down and actually process what you found. That's the feed-forward step. Now, here's where it gets powerful. A transformer isn't just one round of attention plus one feed-forward step. It's layers of them, stacked on top of each other. GPT-2 had 12 layers. GPT-3 had 96. Modern models like GPT-4 and Claude? Over 100 layers deep. Each layer refines the understanding. The first few layers might figure out basic grammar. Middle layers start understanding meaning. The deepest layers handle nuance, context, tone, and that hard-to-define thing where the AI just gets it. More layers equals deeper understanding, but also equals more expensive to run. That's why AI companies spend billions on computing power. All right, let's put the whole thing together. You type, what's the capital of France? Step 1, your text gets split into tokens, individual pieces. Step 2, each token gets turned into an embedding, a list of numbers that captures meaning. Step 3, the embeddings go through self-attention. Every word looks at every other word, figures out what matters, and creates a richer understanding. Step 4, the attention output passes through the feed-forward network, the processing step. Steps 3 and 4 repeat, layer after layer, dozens of times. Each pass deepens the understanding. And finally, the last layer outputs a prediction. The most likely next word is Paris. And then it does it again. Paris becomes part of the input, and the model predicts the next word, and the next, and the next. That's how ChatGPT generates whole paragraphs, one word at a time, each time using attention to look at everything that came before. So now when you open ChatGPT and ask, plan me a trip to Tokyo, you know what's happening. Your question gets tokenized, embedded, run through 100 layers of attention, each one figuring out which words matter, which context to pull in, which patterns apply. And out comes a response one word at a time. When Google translates a sentence from English to Japanese, same thing. Transformer attention figuring out how I love sushi maps to the Japanese word order. When your phone predicts you're about to type on my way, a tiny transformer running on your phone using attention to look at your recent words and predict the next one. It's all the same idea, the same 2017 invention, just scaled up or down for different jobs. Here's what blows my mind about this. The transformer was invented in 2017. That's it. That's how recent this is. 8 researchers at Google published a paper called Attention is All You Need. And that paper is the foundation of every major AI model that exists today. ChatGPT, built on transformers. Claude, transformers. Gemini, Llama, Grok, all transformers. And here's the kicker. All 8 of those researchers eventually left Google. The people who invented the engine of modern AI walked out the door. One more number. That paper has been cited over 65,000 times. It's one of the most influential papers in the history of computer science, and you just learned what it's about. That's pretty cool. So, to recap, a transformer is a way for computers to understand text by using attention, the ability to look at all words at once and figure out which ones matter for each other. It turns your words into numbers, runs them through layers of attention, and predicts what comes next. That's ChatGPT. That's Claude. That's every AI you use. The engine of modern AI. And now you know how it works. If this clicked for you, hit like. It really helps other people find this video. And if you want more explainers like this, subscribe. I'm doing one every week. Next week, I'm tackling what is an AI agent and why is everyone building them? It's the next big thing after Transformers, and I'll make it just as clear. Thanks for geeking out with me. Stay curious.